All right, we finally made it to our last section in chapter 12. So these are the last derivative rules we're going to talk about. Now, there are some that you need to memorize. I think there's 8 or 9 of them. So again, make sure that you print off that worksheet in Canvas and you practice those rules. Fill them out as many times as you need to. Make flashcards, whatever helps you learn and memorize. Because you not only need to know the rules, you have to be able to apply those rules. Those 8 or 9 rules you'll have to memorize for the exam. However, I will give you the exponential rules that we did in the last section, 12.4, and then now I'm going to give you the log and the natural log rules. So you'll see the formula sheet on Canvas also, so you can check that out to see which rules are and are not going to be provided to you on exam day, okay? All right, in this section, we're going to talk about the derivative of logarithmic functions. You can see that we have a couple different formulas here for the derivative of natural log of x and log base a of x. I'm going to call the first one 3a and the second one 4a, just so I can reference it with you. Now you might notice in the bottom box, I've also labeled some of them 3a and 4a, because those are really the same formula, just making sure that we're emphasizing the absolute value of x, making sure that x is positive, both on the natural log and the log. Now if you look on the right side of that bottom one, I have 3b and 4b, because those, just like the exponential functions, could possibly be functions inside of functions, or chain rule. So if it is just an x and we have natural log of just x, then the rule is the derivative of natural log of x is just 1 over x. However, if it's more than just an x and we have junk inside, the natural log of a whole bunch of junk, then really what we have to do is take the derivative of the inside over the inside. Now, just like before, if we memorize these two rules, then we can actually use those all the time, even if we have the natural log of x. If I have just the natural log of x, then I can still use this bottom rule, 3b, and find the derivative. I can take the derivative of the inside, which is 1, over the original inside, which is x, which is rule 3a, right? And so if I can just focus down here at rule 3b, it'll work all the time. Now, if I have the log base a of x and I want to find the derivative, I get 1 over the natural log of a times x. Now, that's just if there's an x. If there's more on the inside, there's a whole bunch of junk, well, then I have to do the chain rule. I do 1 over the natural log of a times the derivative of the junk over that original junk, right? So doing that chain rule if there's more than just an x. Now I do have proofs also for these derivative rules, so you're welcome to look at those to see how we came up with these rules and how and why they work. Those are posted on Canvas, so before you get started you can check those out so it makes a little more sense of how we came up with those rules. But make sure you know how to use those rules and how to look at an equation and figure out what rule to apply. Let's go ahead and do a few examples so we can practice some of these new logarithmic rules. In example number 1, it asks us to find the derivative of each of the functions. So the first one says f of x is equal to the natural log of 6x. Really, this is the natural log of more than just an x. It's a 6x, right? And so what rule would this be? Well, to me, this would be rule 3b. I have the natural log of a whole bunch of junk, right? Not just an x. So the derivative rule says I can just take the derivative of the inside over the original inside. So the derivative of 6x is 6 over the original inside is just 6x. You notice that I should be able to reduce a 6 from the top and the bottom, so I get that the derivative of the natural log of 6x is just 1 over x. You might notice, and I want to point out, that there is no natural log in my answer. As soon as I take the derivative of a natural log, the natural log goes away and I just take the derivative of the inside over the original inside. All right, look at b. b says we have y equals log of x. Now I'm supposed to have a base on my log, but it's not there. Does anybody remember what my base of my log is if it's not actually written? Well, if you remember from back in college algebra, there's actually an invisible 10 there. So really this is log base 10 of x. So what rule does this look like? Well, this kind of looks like rule 4a. Or we could use rule 4b and it would work all the time. If I have log base a of something, even if it's more than just an x, I can use 4b. 4b says I should be able to take 1 over the natural log of my base, so 1 over the natural log of 10, times the derivative of my inside over my original inside. So the derivative of x is 1 over my original inside is x. I can actually combine that into one fraction and really say that my derivative is 1 over the natural log of 10 times x. Let's do one more example, example number 2 in this video. A few more natural log and log problems. If you look at number 2a, we have f of x is the natural log of x squared plus 1. So I have a natural log function with a whole bunch of junk inside. So what rule would that be? Well, natural log of a whole bunch of junk to me looks like rule number 3b. And rule number 3b, the natural log of anything, is really just the derivative of the inside over the original inside. So on this one, the derivative of x squared plus 1 is 2x over the original inside, which is x squared plus 1. Again, no more natural log, so make sure you don't add that in your answer. All right, look at b. Y equals log base 2 of 3x squared minus 4x. What rule does that look like? Well, to me, this looks like rule number 4b. I have the log of a certain base and a whole bunch of junk inside. I can do 1 over the natural log of that base times the derivative of the inside over the original inside. So let's do that here. I have 1 over the natural log of the base, which is 2, times the derivative of the inside, which is 6x minus 4, over the original inside, which is 3x squared minus 4x. I could combine those two fractions, multiplying numerators with numerators and denominators with denominators. I can say that my derivative is 6x minus 4 over the natural log of 2 times 3x squared minus 4x. All right, make sure you know all those rules, that you know how to use them and apply them, and which rule goes with which equation, along with those 8 or 9 ones that you're supposed to memorize from previous sections.